Alright, so this video is a review of best fit models and correlation coefficient. This PlayPosit is going to have practice questions throughout, and this assignment will count as a grade. So for number 1, it says Lisa collected the data of grams of fat and the grams of carbohydrates in 10 sandwiches. So in this table below, they've given us these values and they want us to find the linear best fit model. So to find that linear best fit model, I'm going to put my table into Desmos. Now, I've already prepared my tables to make the video a little bit faster. So in my video here, I can see that I have my table put in for these values. Now I'm going to turn this table on. And in this table, down here in this corner, there's a zoom magnifying glass. That zoom magnifying glass is going to automatically zoom my scatter plot for me. And I can see that it definitely has a strong relationship. So what I want to do is I actually want to find my best fit model. Now, in our previous videos, we've always used Y1 and X1. I'm actually going to be using more than just Y1 and X1 because I've put in multiple tables. So I'm going to do it based off of what the table is asking me to do. All right, so I'm going to add my equation here. So I'm going to do Y1, and I'm going to do my squiggle, which means similar, MX1 plus B. Now, I can see that the R value here is 0.9382, which does mean it's strong and positive. But what I'm more interested in is my M value, which is 0.499, and my B value is 23.229. Now, I always like to do at least 3 decimal places. However, if you look at the examples, they've rounded it to 1 decimal place. So if I round it to 1 decimal place, that 9 is going to round that 4. And we have 0.322, so that's going to remain right at 23. So my correct answer here is going to have my slope and my y-intercept, so my answer is A. All right, so given that, I'm now going to delete that information because we're done with that one. All right, and now we're looking at problem number 2. So problem number 2, it talks about the relationship between the average verbal and math score on a test for 7 states. They say find the best fit model, and we're actually going to do some predictions. We're going to do a prediction if the verbal score is 500. Well, my verbal score is my X score. So if my verbal score is 500, that means my X is 500. So we're going to create the best fit model, and then we're going to actually make a prediction by plugging in 500. Now, I'm going to draw your attention to the fact that in my table right here, if you look, I have X2 and Y2. Okay, this is the second table I put in, so it labeled it differently. So when I do my equation this time, I'm actually going to do Y2 squiggle MX2 plus B. Now, if you're doing one table at a time, which you probably are, you can still use the ones. Again, I'm only using 2s because the table that I'm currently looking at has 2s. And of course, I'm going to zoom fit that, and I can see my scatter plot. And I can see that it does have a very strong relationship. And I can see that my M value is 1.183. And that 8 is going to round that 3 to a 4. And I have negative 32.421. Now, I'm going to make my best fit model with those numbers. So I have 1.184x minus 32.421. Now I'm going to take my x value. This is x equals 500, and I'm going to plug 500 in for x. So I'm going to do 1.184 times 500 minus 32.420. And I got 559.579. Now, if this were all to round up, this would be approximately 560 for the math score. So that was number 2. So I'm going to go delete that, and I'm going to keep going with my next problem. All right, and about a residual, it says the height h in centimeters of a certain plant t days after it's planted can be described by this linear model. If the plant's actual recorded height was 3 centimeters on day 3, what is the residual? So we've got to remember what the residual is and what we're actually describing. So the residual is how good of a fit is my predicted value from the actual value. We're doing the residual, we're going to do the actual minus the predicted. All right, so a few things we've got to determine. Do we have the actual? Do we have the predicted? So when I look at this problem, I can tell that I have the actual value. So the actual recorded height after 3 days is 3 centimeters. So I know that my actual height of my plant is 3. What I don't have is I don't have the predicted value. So the predicted value is what we're going to find using the best fit model. So we have day 3, and we're going to plug day 3 in for t, and that's going to give me my predicted amount. So I have h equals 1.20 times 3 plus 0.14. So if I'm calculating that, if I'm plugging, I can plug that directly into Desmos to calculate it. And I get that the predicted height would have been 3.74. So we're going to subtract my predicted amount. So 3.74. So you got to make sure you're doing the correct order. It's actual minus predicted. So if I subtract those two, 3 minus 3.74, that is going to give me negative 0.74. So why is it negative? So in the video that you talked about with the residual, you talked about the fact that negatives happen because they are below the line. So they're positive if the distance is above the line of best fit. They're negative if they're below the line of best fit. So this prediction is below the line of best fit. Or excuse me, this actual amount is below what they predicted. So my answer for this one is C. All right, so now we have number 4. So for number 4, I'm going to turn that on so you can see my table here is X3, Y3. Again, the only reason it labeled it 3 because it was the third table that I put into Desmos. So I'm going to zoom fit that, and I can see that I do have a pretty strong relationship happening here. But we're still going to put this, these values into my table, and I'm going to put them into Desmos. Now remember, I have to do Y3s and X3s because that's the way the table was labeled. So Y3 squiggle MX3 plus B. Again, you'll probably just use the ones, but for our purposes of not having to put the tables in multiple times, I just went ahead and I'm going to use the different labels. All right, so I'm looking at my value. So my R value here is 0.9895. So that is obviously going to round to 0.95, so I can get rid of A and B. And this is a positive, strong relationship, so the answer here is D. All right, so now we're looking at the correlation coefficient here. So it says, what would be a reasonable correlation coefficient for this scatter plot? So if I'm looking at this scatter plot, I'm looking at what would be reasonable for my correlation coefficient. We don't know exactly, but what could be the best possible answer. So the first thing I'm going to notice is that it's going up. So we're going to get rid of any negatives. So for B, we have a stronger correlation coefficient, and for C, we have a weak correlation coefficient. Now for weak, we would have values that were spread out that did not look like a pattern, but that is not the case here. So if I'm looking at what I do have, I do see that there is a strong relationship here. So the best correlation coefficient is going to be B. All right, so for number 6, it says the correlation coefficient of a set of data is 0.95. So for these statements, so just a reminder, we're not finding anything, but we should remember that our correlation coefficient falls between -1 and 1. And if it's negative, then of course it's going to be going down. If it's positive, that means it's going up. The closer it is to -1 or +1, the stronger it is. The closer it is to 0, the weaker it gets. So 0 is no correlation, and then it's going to get weak as it gets closer to 0. Okay? So I have 0.95. 0.95 is going to fall close to +1. So that's going to be positive, and it's going to be strong. For number 7, a dance team at a school executes a dance move called the ripple. The first dancer in line performs a movement, and then it continues on with each dance performer. The coach notices that the time it took for the dance team to execute that ripple tended to increase constantly with the number of dancers. So she recorded that data in the table. So they want us to write a best fit equation. All right, so this is problem number 7. So for number 7, I've already got my information put in. I'm going to do my scatter plot. I can see that it does have a positive, strong trend happening. And of course, I'm going to look at my table and I have X4, Y4. So I'm going to find that best fit model. So I have Y4 squiggle M X4 plus B. All right, and they want us to write our linear equation. So I know that M equals 0.824. Again, I like to use 3 decimal places. And then I have, for my B value, 0.455. So if I write my model, I'm going to have Y equals 0.824x plus 0.455. Now, the next question says, how long is it going to take for 30 dancers to complete this ripple? So 30 dancers, if I look at my table, dancers is an X value. So we're going to plug in 30 for X. And we're going to figure that out. So we're going to have 0.824 times 30. And we're going to add that y-intercept, so 0.455. So I'm going to calculate that value. And I got that it's going to take approximately 25.2 seconds to complete that ripple. All right, so for the next question, how many dancers will it take if I have a 40-second ripple? So this one's different because this time they're telling us how long is the ripple. So we're going to be looking at a Y value this time. So if we're looking for that Y value, we're going to be taking the 40 seconds and we're now going to plug that in for Y. So this is going to be 40 equals 0.824x plus 0.455. And we're going to solve this equation. So we're going to solve this by subtracting our 0.455. All right, so we have 40 minus 0.455, and that's going to give me 39.545 equals 0.824x. And of course, we're going to divide at that point. So I'm going to take my 39.545, divide it by 0.824, and we get that x is approximately 47.99. So really, it's going to take approximately 45 dancers in total. All right, so my suggestion for a problem like this is always make sure that you know whether you're plugging in for X or whether you're going to plug in for Y. All right, so number 8. So number 8 says that Anna is studying the body proportions for a science project. She has measured the height and the head circumference of 10 people in her class. The results are shown in the table below. So what is the residual? So key phrase here is residual. As we're looking for someone that has an actual height of 65 inches. So if I look at my table, I see 65. So they actually have a head circumference of 9 inches. So in order to do my residual, I need to do my actual minus my predicted. So how are we going to do a predicted value? Well, in order to do a predicted value, you got to have a best fit model. So for number 8, that's exactly what we're going to do. We're going to take our table of values and we are going to find the best fit equation. So again, I have x5 and y5 for this table. So we're going to do y5 squiggle mx5 plus b. All right, and I can write my equation, and my equation for this particular problem is going to be y equals 0.161x minus 1.207. So I have my best fit equation. But now what I want to do is I need to actually find the predicted value. So if I have 65 inches, I'm going to plug that in for x in order to determine the predicted amount. So right here I'm going to plug in 65. And when I plug that in, we're going to get a predicted value for this problem. So we have 0.161 times 65 minus 1.207. So my predicted for this problem is going to be 9.258. Actual head circumference is 9 minus our predicted, which is 9.258. So when I subtract that, I get negative 0.258. So that means that it was my actual point was a little bit below the prediction, okay? And when I'm looking at it, they are a little bit different from what we got, and that's probably because of rounding, but close enough. If we're looking at negative 0.25, the closest value to that is going to be negative 0.23. All right, the other thing that I can look at is if I look at my actual scatter plot. So I can click on those points and I can look and I can see where those points are located. So if I look at where those points are located, I can compare how far do they look like they are from the graph. So like this point up here is much farther than the one right below it. So it's below it, but it's still much closer prediction than the one above that. So just kind of look at it to do a little bit of a comparison. All right. So we're done with problem number 8. Now, number 9 is just really a do you understand how to read a table problem. It says, using this table, what is the meaning of the y-intercept? So the y-intercept, it's asking about the line of best fit, but really it's just an interpretation. So remember, the y-intercept is the initial value. So we're comparing the year since 2005 and the population of a state. So if we're talking about the initial value, we're talking about the initial value that we started from. We don't know when this state was founded. We don't know when it started. So we're talking about the initial value of when the table started. And the table started in 2005. So we're talking about the population in 2005. So we're not talking about when it was founded, because I don't know when it was founded. We didn't go back that far. We can only go based off of the information given. Then we have the average increase in the population each year. That's going to be your slope. The total population increase per year, that's kind of basically the same thing. You're talking about the population increase total. And then the approximate population in 2005. That is what we're looking for, because we're looking for that initial population in 2005. Was an exponential, so we're not going to do that. But I think we've done enough of the best fit models to keep going with that. So for number 11 says the table below represents the time y in seconds that it takes a runner to complete 50-meter race. So if the table is modeled by linear, what is the residual for the time at week 3? So residual, we're talking about the actual minus the predicted. All right, so we know our actual. We know our actual is 7.2. What we've got to do is find the predicted. Well, in order to find the predicted, we're going to have to actually find our best fit model. So for this particular one, we're going to be doing X8 and Y8 because I've already put the table in. So we're going to do Y8 squiggle MX8 plus B. And we're going to write our best fit equation. So I have negative 1.98x my plus 12.92. Now, we need to figure out our predicted amount. Well, how are we going to figure out the predicted? Well, we want to predict week 3. So to predict week 3, we're going to plug in that 3 for my x value. So I have negative 1.98. We're going to plug in week 3 plus 12.92. So negative 1.98 and we get 6.98 as my predicted. All right, so what we're going to do is we're going to now subtract that. So we have the actual time was 7.2. They predicted 9.8. So when we subtract those, we get 0.22. So my residual was off by 0.22 in distance of a unit, and it was above the line. All right, number 12, it says the table below lists the miles Doris drove on a trip and the number of gallons of gas that she used. So it says using a best fit model, it's asking us to find the point that is closest to the predicted value. Now, what I'm going to do for this one is we can definitely plug in each one and see which one is closer. I have no problem with that. What I'm going to do is I'm actually going to show you how to look at this on your table in Desmos. So I'm going to look at number 12. All right, so I'm going to turn 12 on. I'm going to make it zoom fit, and we're using X7 and Y7. So we're going to come here. We're going to do Y7 squiggle MX7 plus B. Now, we have our M and our B. We could make that equation, and we could definitely fit those pieces. We could plug them in, see which one is actually closer, because these are our actual values right here, and we would have to plug in our X values to get our predicted. Well, the great thing about Desmos is over here there's a residual buttons. If you see, it says plot the residuals. Now what it's going to do is it's going to plot these numbers on the x-axis that are actually going to represent the distance. But what I'm more interested in is look at the table now. There is now a table that has been created in your problem that tells you the actual distance that my residual is from it. Now, yes, I could have done this for the previous ones, but I wanted to make sure that everybody understood where these numbers were coming from. So I can actually determine the distance, my residual value for each point. So if I look here, so for 50, my residual, so for 50, my residual is 0.19. For my residual for 125 is 0.04. For 250, my residual is negative 0.27. And my residual for 300 is 0.45. Now the question was which one is the closest. So the closest is going to be which one has the smallest number. I don't care if it's positive. I don't care if it's negative, because positive just means it's above the line. Negative means it is below the line. That doesn't determine which one's the closest. Which one's the closest is which one has the smallest number. So I think about change here. So this is like 19 cent. So this is 19 cent. This is 4 cent, 27 cent, or 45 cent. So the smallest number that we have is going to be 0.4. So that 0.4 means that that is the closest that you are going to get to the actual amount. So the closest one is going to be 1.25. Well, what if I ask you for the furthest one away? So if I ask you for the furthest one away, you're looking for which one has the biggest number. Because the furthest it is away, that means the larger the distance is. So if we're looking for the furthest, we're looking for, so we have 19 cent, we have 0.4, or we have 4 cent, 27, or 45. So the one that is the furthest away is going to be 45 cent for this one. So just keep that in mind. You can look at, if you just hit that residual plot, it'll tell you exactly which one you're looking for. So number 13 says the table below shows the dosage of a medicine a person should take based off of weight. So we have this linear correlation, and it says which one is going to be represented here. So in order to determine the linear correlation, we've got to find R. That's what we got to represent. So in this problem, or in this table, my labels are X9 and Y9. So I'm going to do Y9 squiggle MX9 plus B. And remember, right now we're looking for the relationship. So we have 0.926, or if you want to write the whole thing, 0.956. Now this means that it's going to be positive. So if I look at my answer choices here, so I'm going to kind of highlight. So we have these notations here. So we want it to be positive, so we can get rid of C and D, but it's also going to be strong because it's closer to 1. So the answer is A. The car dealer recorded the selling price of his used cars in 2005. Which best describes the correlation? So again, I need to find my R value in order to determine my correlation. So if I look here and I graph it, I can hit zoom fit. Honestly, just by looking at it, I should see that it's going down. So this should be a negative correlation. Now, if I wanted to, I could most definitely plug this in. And this is a Y10 squiggle MX10 plus B. And my R value is going to be negative 0.909. So again, it is negative and strong. If you have any questions about any of these examples, please let us know. If you have any questions about the residual button, the only thing that I can say, so let's go back and let's look at number 11. So if I put this back in, I can definitely use my residual plot to find that residual value. I don't have to find it by hand, but I still have to know what it means in order to calculate each particular piece. So I'm looking at these values back in my table. Here's my graph. So I have Y1s and X1s again because I deleted everything. All right, so I can hit my residuals plot, and again, it's going to put those values in my table. If you look right here, I can see that at 0, the residual is 0.18. That's my actual minus prime predicted. At 1, I get negative 0.14. So we were looking for week 3. So looking for week 3, we can see the week 3 right here was 0.22, which is exactly what we found. So if you want to use your residual plot, you can use your residual plot in Desmos. All right, if you have any questions, please let us know.